I'm trying to run a project where my Zero Gecko board here talks to a micro SD card. And it's the first time that I'm dealing with this particular processor and SPI peripherals. So I have started with a small exercise, which is an example given by Silicon Labs, and that is the SPI example for this processor. So I have loaded this. This particular example is expected to talk to a memory chip, but it's good enough to see if I can get the SPI signals out of the processor. And let's have a look at how it looks in the logic analyzer. Here we have the captured signal. I've already named the 4 signals according to the SPI standards or conventions. So let's now have a look at what we see here. We see several signals going on. Here you see that everything is reset first, then the chip select activates, there is a clock signal, there is talk going from the master out to the slave, and I even see a reply from my attached SD card, which surprises me a bit because I haven't made any decent code yet to talk to the card. So we'll check now what it's been replying. My chip select is channel 0, clock channel 1, MOSI 2 and MISO 3. I'm not going to check yet which mode it is, I don't know that by heart. I haven't looked that good at the code, but let's analyze here what we're seeing. And I just checked the program so that the analyzer can make more sense out of it. So it's MSB first, and the clock mode is 0, and the first thing that we're sending is a hex 90 to the processor, and let's have a look now at what that gives here. So I have marked it as mode 0 with MSB first, and here is the 90 going out. So now I did the next step, and that is try to port one of the examples that come with Simplicity Studio for one of the other controllers to the Zero Gecko. And I have started by copying that project, changing all the attributes so that it's Zero Gecko compatible, changed code wherever it didn't want to compile, and made a configuration that matches the port and pin use of the Zero Gecko. I did have to change some of the core drivers because the core driver assumes that all 4 pins are running on the same port, and on my Zero Gecko UseArt location 3 the pins are on different ports, so I had to tweak the library a bit, but at least it compiles now. So let's try and run it and see what it does on the logic analyzer. I'll start by priming the analyzer here, then go to my code, run it, and let's see what's captured. Very good. Not a lot. Oh, some things are happening. My main worry is that the clock doesn't seem too eager to do something, so that's not okay. I have master out going out, nothing coming back from the chip. So it seems that I do have an issue. Chip select seems to work. The clock doesn't behave as needed. So I'll now have to debug and see why the original example worked and my example doesn't want to do anything. I have found what the issue was with my example. I missed this particular assignment here of the location of the SPI port. My configuration had location 2 here, while everything else points to location 3. So now I have compiled this and I'm running my example. I have my logic analyzer already in wait mode, so let's see what it captures. Here we go. I have some communication both from master and slave. So let's look at the SPI analyzer. I think it's good news, I'm not sure yet. The mode should be 0, MSB first, and then 0, 1, 2 and 3. Let's now analyze and see what we have. A whole number of communication. Hey, and I just plugged the SD card in my computer and I have a file here called test.txt and let's have a look at what it says. EFM32, the world's most energy-friendly microcontrollers. And if I look at my source code, what are we trying to write? Yes, so success. The port was successful, a silly mistake of myself to not fully review all the settings, but once that was done, I have what I needed to have.